Final presentation, energy and transformation to moving cart. The problem stated is how fast will the cart move with the different sets of extra weight added. This project is about building a small cart that will have different sets of extra weight to see if it moves faster or slower depending on the amount added. It applies the second law of Newton, which I have studied since last semester. Here we can see some of the formulas I used for this problem in the theoretical framework. First, we have Newton's second law of motion, which is acceleration equals the net force divided by the mass. Then we have, consistent with the above equation, a unit of force is equal to a unit of mass times a unit of acceleration. By substituting standard metric units for force, mass, and acceleration into the equation, the following equivalency can be written as 1 Newton equals 1 kilogram times meters per second squared. There is a possibility that friction is present on the surface in which the cart is gliding. In this scenario, it is important to mention that there will be a slight change on the formula used. As said before, the formula is the force equals mass times acceleration. The variables here are the independent, the weight that is added to the cart; dependent, the speed at which it's moving; control, the environment; moderator, how the person moves the cart; extraneous, the possible friction on the surface. Here we can see some evidence photos, or the photos that I took of my prototype. The materials used for this project were Lego blocks and pieces, small toy wheels, 7 different size Lego blocks, and a horizontal surface. In the method, there will be multiple trials, each with a different weight added to the cart. The cart will move faster or slower depending on the extra pounds. This will prove the second law of Newton, and the information gathered will be helpful to fill the observations in data chart. The speed of the cart will be evaluated and shown on this stage of the project. The cart is supposed to go at a slower pace the higher the weight, and the lighter it is, the faster it will move. But that is basically the purpose of this experiment. Next, we are able to see the results. This includes the observations and data. On the left column of our chart, we have the weight added in newtons. Notice how it goes from the highest weight to the lowest weight. On the right column, we have the average speed in meters by second, with an uncertainty of plus minus 0.05. The average speed was obtained using the formula for speed, which is the speed equals distance divided by time. Next, we see the hypothesis that states that the more weight is added to the cart, the slower it will move. The Excel graph shows us how this cart behaves. It's a linear graph, meaning that on the x-axis we have the weight added in newtons. On the y-axis we have the speed in meters per second. As the hypothesis states, the more weight is added to the cart, the slower it moves, or the less speed it has. Conclusions. By doing this very interesting project, I can finally state that the hypothesis was successfully met. It's a fact that the more weight a given mass has, the slower it will move. With all the trials done and different sets of weight added to the Lego cart, I proved my hypothesis right. I also learned more about the second law of Newton than I already knew from my classes. I applied some of the knowledge acquired in my physics class to support me during this project. Thank you so much for your attention. I hope you liked my project of the moving cart built with Legos.